How am I supposed to finish this now?
Wait, isn't the deadline like tomorrow?
Yeah,
And it's 10 o'clock, 2 hours before the deadline.
Exactly, we're kinda in a pinch here.
You do remember what our project is, right?
yeah, it's a miniature power generator, right? Why do you ask?
Why don't we just use that?
We've been working on this for so long that I kind of forgot what this was all about.
Well, you know how a ton of food is wasted every day at our school canteen? Well, we thought that it was a waste to have all that just be thrown out. Then we stumbled upon the idea of converting food waste into energy. Thus, H.O.U.N.D was born.
Alright, now that we are all freshened up on the origins, let's go through this one last time. How is what we call a miniature biogas energy generator. It is technically classified as an anaerobic composter, which makes use of microorganisms that don't require oxygen.
There are currently three parts to our project. First is the main decomposer. It is a space for the food waste to be decomposed by bacteria, namely methanogen. We add cow dung and food waste into the main decomposer and seal in shut. The methanogen break down the food waste and biogases is released, which contain a number of gases which include methane, carbon dioxide, and hydrogen sulfide.
This brings us to the second part, the H2O based purifier. As previously mentioned, the biogas contains a small amount of hydrogen sulfide. Well, it's only a small amount. It won't hurt, right? Wrong. Hydrogen sulfide is lethal if absorbed into the body at high concentrations. It may cause death, and at low concentrations, eye irritation, headaches, and a fatigue. That is why we purify it using a simple reaction. The hydrogen sulfide is guided into the water by the pipe and reacts with the water, forming sulfuric acid as a result, and removing the poisonous hydrogen sulfide from the gas. The gas that comes out is mainly methane and carbon dioxide, around 60% and 40% respectively. The gas then travels through this pipe here and goes into the balloon, but we prefer the term gas container. This gas can be used for cooking or heating things, or you can use it to generate electricity.
And this is the most important part of the project, the part where the energy is generated. What happens is the glass syringe gets heated by the flame generated by combusting the methane gas. As you can see, there are two syringes or chambers here. One of them will be heated, which will force the air to expand and push the flywheel half a rotation. The air then travels through the pipe, where it is then cooled down and made to contract. The flywheel then turns the full rotation. The flywheel is connected to a generator which turns the kinetic energy into electricity.
We also have an online application that allows us to remotely monitor the pressure of the gas container and chamber of the main decomposer.
Though similar solutions do exist, in Malaysia there are few and far between. There are two biogas power plants in Malaysia. One is privately owned and one is owned by Sime Darby, a Malaysian conglomerate. These power plants, though more effective than our own, are multitudes bigger than ours, meaning they need more manpower to maintain and are inaccessible to the common folk. Our project is meant to be in every single household across Malaysia so that everyone has access to clean and affordable energy.